Okay, perfect. Hello, hi, good afternoon, my dear students. How are you all? I hope that everybody is perfectly fine. And this is Ritika, your chemistry educator, welcoming you all to the amazing YouTube session of Unacademy. Okay, hi Samriti. Ma'am, please chemical changes and reactions में भी session लीजिए. Okay, yeah, Samriddhi. So actually, chemical reaction and changes, it's not a topic of your term two, right? So that is why right now we are going for all the topics that are going to come in your term two examinations, right? But there is a good news for you that from 15th of March, we are going to start a session, okay, in which we are going to take all the topics, okay, term 1 and term 2. So basically we are going to start a new session, and from that day, that is the 15th of March, we are going to start the chemical reaction changes and all the other topics, okay. So about me, I am Ritika, your chemistry educator. I have completed my engineering in electronics and communication and have been awarded grade A by Cambridge English EOSL. Now today we are going to have a very important session. These 15 days we are going to solve some question paper, we are going to solve some previous year questions and a one-shot kind of revision series, right? So students, you can join me on my Telegram channel for any assistance in the homework or the class notes. Also, you can join the official Telegram channel of Unacademy so that you can receive the information regarding the classes, the batches, or the plus sessions, or all the ongoing discounts. Okay, so kindly make sure that you join both these Telegram channels. Okay, so in our today's session, basically we are going to study about hydrogen, and we are going to focus on certain things such as the position of hydrogen, the preparation of hydrogen, etc. Okay, now talking about hydrogen. So hydrogen, it is the first element of our periodic table, right? The position of hydrogen, it has always been a kind of confusion, okay, but we have got the position, the first position, or the topmost position for hydrogen in the periodic table. Now before moving on to learning more things about hydrogen, we will just know a bit about hydrogen. We will know about the basic things, that is like the symbol, formula, etc. So if I talk about symbol of hydrogen, it is H, capital H. Now molecular formula. Basically what the molecular formula is, that how many atoms are combining to form one molecule. Okay, so in the case of hydrogen, what we are having, see, there is hydrogen, it has got only one electron, right? So there is one electron, and from the other hydrogen we get one electron. They both combine, okay, and they form a diatomic molecule. So the structure of hydrogen, it would be somewhat like this. Okay, so there are these two electrons, okay, they are shared by two hydrogen, and therefore we get the molecular formula as H2. Next thing is the valency. So hydrogen, it can follow the valency of negative or positive 1. Okay, so it can either lose one electron or it can gain one electron. Basically it has got valency of 1. Next is the relative atomic mass. So if I talk about the atomic mass of hydrogen, it is 1, and molecular mass, it is 2. Why? Because there are two atoms of hydrogen, they combine to form one molecule, which makes the molecular mass as 2. Atomic number, since it is the very first element of the periodic table, okay, we are having atomic number as 1. Then electronic configuration. So if I talk about electronic configuration, it is present in the first shell, since it is having only one electron. So it is present in the K shell. Okay, the one electron, it is placed in the K shell. Okay, why the valency of hydrogen is 1? Okay, why is it 1? Let me tell you. See, hydrogen, if I talk about, it has got one electron in the outermost shell. Okay, so what can it do? It can either take one electron, okay, to achieve the nearest noble gas configuration, that is helium, that will be a stable configuration, or it can give one electron, okay, to form a cation. Okay, so basically either it is taking one electron or it is giving one electron. So that is why the valency is 1. I hope, Samriddhi, you have understood this. If you need some more help, please let me know. Next is the position in the periodic table. So if I talk about the position of hydrogen in the periodic table, it is given the topmost position. So it is present in first group and first period. So first period and first group, 1A group. Okay. So these are some of the general things about hydrogen that you should be knowing before we go on for a further, or I would say, deep study. Okay, so hydrogen, it is the first element of our periodic table, having the atomic number as 1. Why? Because it has got only one electron in the valence or the outermost shell. Okay, now although it's placed at the topmost position, but actually its properties are kind of varied. Okay, so it really doesn't belong to any particular kind of group in the case of all the properties. Okay, so there are some things which are not same, there are some things which are same. Okay, therefore the properties or I would say the position of hydrogen, it is very much confusing. Okay, from which book are you teaching? So right now, since it's high time for your examinations, I'm referring your basic, or I would say standard book, that is Selena. Otherwise, when we have much of time, we are taking the reference from various other books and question papers. Okay, so right now it's very important that you have a thorough reading of your standard book. Okay, so since it is placed in the first group and first period, you might think that okay, all the properties should be same as in case of the group 1 metals. But that is not the case over here. Okay, some properties, they of course are same, but not all. Some properties are very much different. Okay, and therefore this position of hydrogen, it has always been a matter of controversy, or I would say confusion. Now why there was a problem regarding the position of hydrogen? So the reason why the position of hydrogen was a confusion, because hydrogen, it showed the properties which were similar to alkali metals and also halogens. Okay, so some properties of hydrogen, they are similar to alkali metals, some properties they are similar to halogens. Okay, now it is said that whichever elements they are having same type of property, they come under the same group. Okay, but how to place a single element into two groups? So that is why we placed or Thomson, because of Thomson's suggestion, we gave a separate position to hydrogen, that is on the top of the periodic table. So the basic reason for that was so that it doesn't disturb the whole symmetry of modern periodic table. Acha. Now we will be discussing the properties of the hydrogen which are similar to the alkali metals and the halogens. Acha, if I talk about alkali metals, what are the alkali metals? That is these are the alkali metals, right? Lithium, sodium, potassium, rubidium, cesium and francium. And if you have seen the periodic table properly, you will see hydrogen placed on the top of it, right? So why is it placed over here? We have already discussed that, so that the whole symmetry of periodic table doesn't get altered, and also the reason is some of the properties of hydrogen, they are somewhat similar to alkali metals. Okay, so let's discuss what are the properties and how are they similar. If I talk about very first property, that is the electronic configuration. Acha, if I talk about hydrogen, so what is the atomic number? It is 1. Okay, so what will be the structure? Basically this will be the nucleus, and this is the first shell, that is the K shell, and it will be having 1 electron over here, right? If I go for some alkali metals, for example lithium, the atomic number, it is 3, and therefore the configuration of lithium, it will be 2,1. Okay, now if I go for the diagram, it will be, this will be the nucleus, this will be the first shell, and this will be the second shell. So in the first shell we have 2 electrons, in the second shell we have 1 electron, right? Talking about sodium, we are having atomic number as 11. Okay, and the configuration goes on 2, 8 and 1. Now if I go for the diagram of this particular sodium, then this will be the nucleus, this is the first shell having 2 electrons, this is my second shell. Now in second shell it will be having 8 electrons, 6, 7 and 8, and it will be having one more shell. Okay, and in the last shell it will be having 1 electron. Now students, do you see any similarity or any similar property in the case of hydrogen, lithium or sodium related to the diagram? Can you please let me know what are the similar properties if you have, or if you notice any? Now if I talk about the similar property, you can see that over here we will be having 1 electron in the outermost shell, right? So if I talk about the outermost shell, hydrogen, lithium, sodium, potassium, rubidium, cesium, they all will be having 1 electron in the outermost shell. Okay, so that is, I would say, the basic similarity between the hydrogen and alkali metals. So we can write that they are having 1 electron in the valence shell or the outermost shell. So that becomes the first property. Not only up till sodium, we are having same configuration or similar configuration for potassium, for rubidium, for cesium, etc. Next is valence electrons. So if I talk about the case of hydrogen, it is having 1 valence electron. What are valence electrons? Basically the electrons present in the outermost orbit. Okay, so for example magnesium has 2, chlorine has 7, hydrogen has 1, and all the alkali metals, they are also having 1 valence electron. And because they all have got 1 valence electron, that is 1 electron in the outermost orbit, their valency will be equal to 1. Correct? So what is the reason? Having 1 valence electron. Acha, next is ion formation. So before going on ion formation, let's know what is ion. So If I talk about any metal, let us say that this is the metal, okay, in its normal state, having 2 electrons in the first shell. Let's say it's having 2 electrons in the second shell also. Now, what is the basic tendency of elements? They need to be stabilized, okay, they need to have a stable configuration, right? And for stable configuration, the elements, they need to have at least I would say 8 electrons in their outermost shell, okay. The only exception over here, it is hydrogen and helium, which have got 2 electrons in their outermost shell. Now, since it has got 2 electrons, this particular element, it has got 2 electrons in the outermost shell, it has got 2 conditions. It has to actually make 8, okay. So it can either take 6 electrons or it can donate its 2 electrons, right? There are these 2 conditions. Now, obviously, students, what will be easy? Just taking 6 electrons or donating 2? I guess the donation of 2 electrons, which it will be much more easier. So what it will do, it will give out its 2 electrons, okay. And when it gives out the electrons, it will develop a charge, okay. And when any element or any atom, they donate or gain electron, they develop a charge, they are said to be ions, okay. How many type of ions do we have? We are having 2 type of ions. One is positive ion and the other one is negative ion. This positive ion, it is also known as cation, and negative ion, it is known as anion. Now, when do we have the positive ion formation? So whenever any element, it donates the electron, okay, it gets a positive charge over it, and we say that it is a cation, right? And negative ion, if I talk about, if they take or if they gain the electron, they achieve a negative charge, and we say that it is the anion. Hope that it is clear. Now, talking about the ion formation in the case of the alkali metals and hydrogen. Okay. The alkali metals, since they are having 1 electron in their outermost shell, so it becomes very easy for them to, give or donate 1 electron rather than gaining 7 electrons to achieve a stable configuration. Okay. So what do they do? Lithium, it has got how many electrons? It has got 3 electrons. Atomic number is 3, configuration is 2, 1. So it will give out its 1 electron to achieve a stable configuration. And what will be the charge? So this lithium, it gives out its 1 electron, okay, and what will happen? It will get a positive charge. Similarly, if I talk about sodium, having the configuration, the atomic number of 11, and the configuration, it is 2, 8, 1. So again, it will be giving out its 1 electron and it will be having a positive charge. Okay. And similar to these alkali metals, hydrogen behaves. Hydrogen gives out its 1 electron and it also develops a positive charge. How? Let's see. So it can give and it can have a positive charge and electron. And since they are forming the positive ions, so what they will be known as? Can anybody let me know in the chat box? The positive ions are known as, okay, you have your chemistry exam, so all the very best, please do well. Okay, there are some tips that I would like to give. Just relax. Okay, do the questions that you know very well first. Keep your paper clean. Okay, and just go on revision for the important topics at the last moment. And again, I wish you all the very best. Please do well. Okay, moving on to next thing. Yeah, I was asking that what is the positive ion known as? So the positive ions, they are known as cations. Correct? So they form the cations. And since they are forming the cations, they are having the electropositive nature. Now there is this word electropositive nature. What do we mean by this? Can anybody let me know in the chat box what do we mean by the electropositive nature? I'll be waiting for your answers, and after reducing power I'll be explaining you what do we mean by electropositive nature. Acha, if I talk about the reducing power, hydrogen and the alkali metals, they both react, or they both act as reducing agents. How? Let's see. So if I take copper oxide and if I make it to react with hydrogen, what will happen? I will get copper, okay, and water. So over here this hydrogen, it is acting as reducing agent. Similarly, in the place of hydrogen, if I take sodium with the same compound, I will get copper plus oxide of sodium. So they both are over here acting in the similar manner, and they are acting as reducing agent. Now talking about electropositive nature. So before burning, let's study about electropositive nature. Acha. Basically, electropositive nature means how easily any element can give out its electron. Okay, so that means it is highly electropositive. Let's take some cases. For example, if I'm having lithium, okay, so lithium, it will be having two shells, right? These are the two shells having the electrons. Okay, now this lithium, it will be giving out its electron easily as compared to fluorine having the atomic number of 9 and the configuration of 2,7. Here it is 3, configuration is 2,1. Okay, now over here what is the thing? It will be also having two shells, okay, and the electrons will be accommodated as 2 in the first shell and 7 in the second shell, that is the outermost shell. So this is the basic configuration. Now talking about the electropositive nature, see students, lithium, it requires 1 electron, okay, it requires 7 electrons to achieve a stable configuration, and as I told you that it is basically easy to give 1 electron rather than having 7 electrons, okay. And if I talk about fluorine, it has got 7 electrons, okay, so it will require only 1 electron, okay, to achieve a configuration. So since lithium, it will be giving or it will be donating the electron, it will achieve a positive charge, okay, and that is why it is said to be electropositive in nature, okay. And fluorine, on the other hand, it will be gaining the electron, okay, and when they gain electron, they get a negative charge and they are said to be electronegative in nature. So basically this is the formation, or I would say the difference between the formation of anions and cations, or having the electropositive nature and electronegative nature. I hope that up till here you might have understood, okay. So kindly remember that the hydrogen along with alkali metals, it acts as electropositive in nature, okay. Now if I go for the other thing, that is burning, just a minute, yeah. So if I go for the other thing, that is burning, hydrogen, it will burn in oxygen to give the oxide. So hydrogen we are having over here, when it reacts or when it burns in oxygen, it will be giving its oxide. Okay, and what is the oxide of hydrogen? It is water. How it is formed? H2 plus O2, it gives us H2O. So if we need to balance the equation, yeah, okay, all right, just a minute, yeah. So this is the oxide of hydrogen that is formed. Acha, now if I talk about alkali metals, how are they similar to hydrogen in this case? Let's see. When any alkali metal, it burns in oxygen, it will also form the oxide. For example, let's take the lithium case. So when lithium it burns with oxygen, it forms the lithium monoxide. Okay, so this is the basic condition. Sodium also forms, potassium also forms. Okay, so basically the metals, they react with oxygen and they form their oxide. Okay, that is the general formula. Okay, alright, so these are the basic similarities. Okay, if I talk about next, it is the combination of non-metal. Now when hydrogen it combines with non-metals, it forms the various compounds. For example, if it combines with oxygen, it forms what? Water. When it combines with chlorine, it forms hydrogen chloride. Okay, so I'll just write it over here. We can have water, we can have hydrogen chloride, we can have hydrogen sulfide, etc. Now, if I talk about other elements such as sodium or lithium or potassium, they are also reacting with non-metals and they are giving various compounds, okay, such as sodium chloride, okay, sulfide or oxide, etc. So these are the compounds that we can get. So over here also we can see that there is a similarity between the hydrogen and the alkali metals. Correct? Next is, okay, before going on next topic, there is a very important information for all the students. So as you know that this is a very high time, okay, your examinations are also going to happen and your new session is going to begin very soon. So students, Unacademy is launching a very amazing offer on 1 year or above subscription. Now this is a very limited period offer, so kindly hurry up. If you take the subscription of 1 year or above, you will be getting whole 6-month extension on your subscription. Okay, so students, it's humble request that kindly hurry up and kindly go for plus subscription. You can use my code RITIKACLIBE. Now this code, it will give you extra 10% discount. Okay, so basically you just need to pay for 1 year and you are getting the subscription of 1.5 years. Okay, and also if you are having any confusion regarding the subscriptions and all, you can join the Telegram channel and you can let us know over there. Okay, now moving on to next thing, that is hydrogen and halogen. So as I told you that hydrogen, it is having the properties which are similar to the alkali metals and the halogens also, right? So we saw all the properties which are kind of similar between hydrogen and alkali metals. Now we are going to see what are the properties which are similar between halogen and the hydrogen. Very first is electronic configuration. Before explaining you that, if I go for the atomic number of hydrogen, it is 1. The atomic number of helium, it is 2. The atomic number of fluorine, it is 9. Okay, and the atomic number of neon is 10. Atomic number of chlorine, it is 17. And the atomic number of argon, it is 18. Now what is this? Let's see. Talking about hydrogen, the configuration, it will be 1, and helium it will be 2 in the first shell, right? In the case of fluorine, we will be having 2, 7, and in the case of neon, it will be 2, 8. And for chlorine, we will have 2, 8, 7, and argon, it will be 2, 8, 8. Now, what is the similarity that you are seeing over here? Hydrogen, it has got 1 electron less than the nearest noble gas, that is helium, right? Similarly, fluorine, it has got 1 electron less than the nearest noble gas, that is neon. And chlorine also same thing, 1 electron less than the nearest noble gas. So all the halogens and hydrogen, they are having 1 electron less than the nearest noble gas. So what we can write? We can write that they are having 1 electron less than the nearest noble gas. So this is the similarity between hydrogen and halogens, right? Next is the valency. So their valency is 1. Okay, they accept 1 electron. Okay, and they attain the electronic configuration of nearest inert or noble gas. Correct? Now, next is formation of ion. Now, if I go for the formation and how are the ions formed over here in the case of the halogens, we will be starting with fluorine having atomic number of 9, configuration being 2, 7. In the first shell, fluorine has 2 electrons. This is 1 and this is the second electron. And in the second shell, the fluorine, it has got 1, 2, 3, 4, 5, 6 and 7 electrons. So as I told you, they need to achieve stability, and that can be, got by nearest noble gas configuration, right? So for that, fluorine, it needs 1 more electron, that it is 1 electron short, right? So it will actually gain, or it will take 1 electron, okay, to achieve the nearest noble gas configuration, correct? And since it is taking 1 electron, it will have a negative charge, okay, and it will be forming an ion. And the hydrogen also, in some cases, it can act as an ion. So basically what is happening? They are taking the electron and they are getting the negative charge. Chlorine, fluorine, every halogen, it reacts in the same way. Yes? Okay. After that, the next thing is the electronegative character. Now basically what do we mean by electronegative character? It is, one is electropositive in the case of metals that we saw, and electronegative is when they take the electrons, okay? So they are electronegative and they take the electron, or they accept the electron to achieve a negative charge. Okay, so that is the basic thing. Next is the physical state. So if I talk about halogens, they normally exist as gases, fluorine, chlorine, etc. And hydrogen, it also is gas. So they exist as gases, correct? Now atomicity. What basically is the meaning, or what do we mean by atomicity is the number of atoms in one molecule of a substance. Correct? Now if I talk about hydrogen, we all know that it exists as H2. So if two atoms combine to form one molecule, it is known as diatomic. And similar to I would say hydrogen, the halogens are also existing as diatomic, right? So basically we have H2, we have F2, we have Cl2. That means they exist as diatomic molecules. Their atomicity is 2. Okay, so up till here I guess the things are very much clear. Okay, if there is any confusion in any of the thing that we have covered till now, kindly let me know in the chat box. Now we have discussed the properties which are kind similar to the hydrogen and the alkali metals and the halogens. Okay, but this is not the case. Not all properties are similar to the halogen or alkali metals in case of hydrogen. There are some of the properties which are pretty much different. How different? Let's have a look. The very first is number of shells. So if I talk about hydrogen, since its atomic number is 1, it needs only one shell to accommodate its electron, right? So in case of hydrogen, the number of shells is 1, right? And in case of all the other elements, or to be very precise, if I talk about the alkali metals and halogens, they are having minimum 2 or more shells. So that is the basic difference. And next is the oxide nature. So the oxide which hydrogen forms, that is the water, it has got neutral nature. Okay. Then talking about the oxide of alkali metals, they are having basic oxide nature. And talking about halogens, they are having acidic nature. Okay, so over here in these 2 points, the properties of hydrogen, they are entirely different from the alkali metals and halogens. Now talking about the discovery and occurrence of hydrogen. So hydrogen at the very first, it was also termed as inflammable gas. And this elementary character of hydrogen, it was established by Robert Boyle. The very first time when hydrogen, it was prepared in the pure state, it was done by Henry Cavendish, and he was the one who found that this gas, it was inflammable, it can burn in air to produce water. Basically the name hydrogen, it was given by Lavoisier, and hydrogen, the name means hydro and gen. Hydro means water and gen means produce. So it means water forming or water producing gas. Okay. Next is the occurrence of hydrogen. So hydrogen, it can occur in the free state, in the combined state, etc. Talking about the free state of hydrogen, it exists or it makes up approximately 1% of Earth's crust, and it's normally not found in the free state on the Earth. Okay. So it exists very less, up to 0.01% in the atmosphere. It is found in a little bit quantity in volcanic gases, and it's found in a good quantity around the sun and the stars. Okay. Now next is the combined state. Okay, so if I talk about the combined state, hydrogen, it is found in the combination with other elements in the combined state. So it can occur in the plant or animal tissues. The compounds, they are made up of hydrogen and carbon and oxygen, nitrogen, etc. It is also found in water. So about or approximately 1/9 of mass of water, it is of hydrogen. Next, it is found as constituent of different substances, that is, it is found in the acid, in the alkalis, the petroleum products, the organic substances, etc., etc. And when we combine it with carbon, it can be found in natural gas or kerosene or gasoline and petroleum products. Also, hydrogen, it is the constituent of organic substances like protein, carbohydrate, fats, etc., etc. Okay, so these are the essential components for living matter. Okay, students, talking about Unacademy's free special class. So you can attend the special classes. These are absolutely free of cost. Okay, over there we have real-time interaction, we have chats, emojis. You can ask the question using question tab. We have live poll options. We have poll leaderboards, etc. And talking about the special class timetable, so this is our next two classes planning, or I would say timetable. On 3rd March, we are going to discuss on the periodic table. So we are going to have a full revision on periodic table, and on 6th March, we are having the revision on pollution. So these are topics of your term 2 examinations, and at 5:15 p.m. we are going to meet on 3rd and 6th March to have a revision. Okay, why Unacademy? So Unacademy provides you some of the very amazing features. Okay, so you can learn from the comfort of your home. You will be having the unlimited access to all the courses. You will be taught by top educators of India at one platform, and not just the regular classes. You have the doubt clearing session and the answer writing session. So in the doubt clearing session, all your doubts are taken care of. They are cleared in the best way possible. Answer writing session basically teaches you how to attempt the questions. Then you get all the study material in the PDF format. We have practice test, live test, batch courses, etc. And apart from this, you will be getting your daily practice section, your weekly mock test series, live quizzes, daily MCQ, etc. Talking about the subscription plans, so you can go for any subscription plan, 3 months, 6 months, 12, 24, 36, anything. And you can use this code to get extra 10% off. Now students, as I told you that right now Unacademy has launched the offer. So if you take 12-month or above subscription, you will be getting 6-month subscription absolutely free, right? So kindly go and avail this opportunity. Next is preparation of hydrogen. So if I talk about preparation of hydrogen, the cheapest raw material that we can have, it is the acid, the alkali, and the water, right? So these are the materials which are used in the preparation of hydrogen, but they do not react in same way. There is a different method of reaction for each. Let us discuss one by one. The very first is hydrogen from cold water and metal. Okay, if I talk about how can we get hydrogen from cold water and metals, there are some reactive metals, right? For example, sodium, potassium and calcium. Now these are the three metals which can give hydrogen by the action of cold water. If I go for example, potassium. If it reacts with water, kindly remember to balance the equations. So what does it give? It gives the hydroxide and hydrogen gas. Over here, the thing that you need to remember that this reaction is very vigorous. It's highly exothermic and it catches fire. Okay. So over here, see, when I write H2O, it doesn't tell me if the water taken it is hot, cold or in steam form. So kindly make sure that you mention over here that it is cold water. Next is talking about sodium. So sodium also gives very vigorous and prompt reaction. Now we are using sodium amalgam or potassium amalgam. Now basically what is it? It is sodium plus mercury. It's an alloy of sodium and mercury. And what is the use of sodium amalgam or potassium amalgam? It is used to slow down the reaction. And with this, the reaction can take place very smoothly. It doesn't catch fire. Okay, so to reduce the rate of reaction or to make the reaction go very smoothly, we can use sodium amalgam or potassium amalgam. Next is the calcium. So calcium also reacts, but the reaction is a bit less vigorous than that of sodium and potassium. Next is action of hot water. So we have magnesium. Okay, so magnesium basically it gives a bit of slow reaction and it forms magnesium hydroxide and hydrogen. How? Let us see. When it reacts with water, over here it is hot water. It will be giving magnesium hydroxide and hydrogen gas. Okay. And it can also react with steam. So if this magnesium it reacts with steam, it will be forming magnesium oxide. Okay, it will be white ash and it will liberate hydrogen gas. Okay, so this is how they react with hot water. Next is reaction on, or I would say the action of steam. If I talk about the elements such as aluminium or zinc or iron, they react with steam to give the hydrogen, right? For example, let's take the case of zinc. When it reacts with water, it gives zinc oxide plus hydrogen. When it reacts with ferrous, it will give, now over here with ferrous, the reaction is reversible. So if we do not remove this hydrogen which we get, it will again be reduced back to the iron. Okay, so these are the basic reactions. Hope that you might have understood up till here. Now we'll solve some of the questions before moving further. So these questions are basically related on whatever we have learned in our today's session. The very first question, the usual valency of hydrogen is dash. So can anybody let me know what is the basic or what is the valency of hydrogen? The valency of hydrogen, it will be either -1 or +1, as in the case of halogens and the alkali metals. The correct answer is +1 or -1. Next is the credit of discovery of hydrogen. It goes to dash. So Henry Cavendish, he discovered the hydrogen gas and it was Lavoisier who gave the name to the gas. Next is the properties of hydrogen that resemble with alkali metals are dash. So alkali metals, they form positive ions, right, which are known as cation. So that is the correct one. Electronegative character is not a property of alkali metals. They are highly electropositive. The electronegative character, it is the property of halogens. Next is both hydrogen and halogen require one electron to achieve stable electronic configuration, that is of the nearest noble gas. So yes, hydrogen, it is nearest to helium, okay, and all the other halogens, they are again near to the respective gases such as neon, argon, krypton, etc. So that makes the option true. By which metal which metal can give hydrogen by action on cold water? So we just now saw that sodium and potassium, they are giving a reaction with cold water. Calcium is also giving, so it is all of the above. Okay, so sodium, potassium, calcium, they give very vigorous reaction. Okay, they are exothermic reactions and they give hydrogen with cold water. Next is dash reacts with steam to produce hydrogen. So which metal it reacts with steam? Anybody? If I talk about steam, magnesium, it is the metal which reacts with steam and it produces hydrogen. Okay, after that, what percent of matter in universe it is believed to consist of hydrogen? So in the universe, hydrogen, it is present in huge quantity. So approximately 75% of universe it is believed to have hydrogen. Next is the name hydrogen comes from words meaning dash. Now hydrogen, it is hydro plus gen. Hydro means water and gen means producer or former. So basically this is the correct option, water forming. Okay, so students, I hope that you might have understood everything that we have covered in our today's class. If there is any confusion or anything you haven't understood, kindly let us know in the chat box. Also join the Telegram channel and press the bell icon, subscribe to the channel of Unacademy, okay, so that whenever the new videos come, you will be notified. And also join the special classes so that you can receive a whole revision of your term 2 examinations, right? So thank you very much and all the very best for your examination preparations. We will be meeting in the next class, in which I will be bringing with me some other important sessions regarding your term 2 examinations. So till then, students, keep learning, keep studying, take care of yourself. All the very best for your examinations. Bye.